Hello, my name is Brooke Conrarty, and today I will explain my VBA project. This project takes steps to solve a problem that can affect most psychology studies which involve manipulation of a participant. Specifically, this project focuses on whether or not to include a participant's data. The data will be included or excluded in an experiment based on their initial qualification to participate and the degree to which they suspect they are being manipulated. This particular experiment focuses on cognitive dissonance and how a person may reduce this dissonance, whether through rationalization or misattribution. Dissonance is the uneasy feeling caused by behaving in a way that is at odds with one's beliefs. How you construe your behavior can then affect how you reduce your dissonance. The study I've created today is a theoretical study modeled after a real study being completed in the psychology department. We ask students a question in order to determine how they would feel about it initially. And the question we asked in this study is, should we change our colors to red and gold to match our sun devil friends? Initially, most students will say no and give a lower rating in this initial rating box. We then ask students to write an essay in favor of the change, either asking for the essay to be written voluntarily, which is a high choice, or by mandate, which is a low choice. Most, though not all, students will not feel good about doing this and will want to find a way to reduce the tension caused by writing in favor of something they don't believe in. Some students will change their attitudes and will believe that we should change the colors by the end of the experiment. We call this process rationalization. It's a tendency to change our beliefs to match with our behavior in order to reduce our tension. Other students may blame the current situation for their tension, such as the temperature of the room, claiming it's too cold. We call this process misattribution, which is a tendency to blame the situation. These can be affected by the construal of the behavior, either abstract or concrete, but I won't go into that today. It's a little too complex for this particular program. So the first step is to identify which participants are high choice or low choice conditions. And this can be done by color coding based on the numbers. I already had them color coded, but I turned them back to white in order to show you how we can do this. This particular button will do this for us. It will code based on the number inside these boxes and let us know what our particular settings are. As you can see, we had our high choice number 1 as a blue color. We did low choice as purple. We had abstract as red, and concrete as green. We then take the associated initial and final ratings and graph them to look for a relationship. In the high choice and abstract, we expect to see the widest range, expecting the rating to rise the most based on these manipulation factors. In the others, we would expect to see a more closely bunched grouping, such as this one, as there's less dissonance or the dissonance is being solved in other ways. However, in all of these graphs, we can see outliers, and our goal today is to make it possible for outside data entry personnel to exclude those data from the graph. When we go back to our participant data sheet, we can see that certain things are very easy to include or exclude, such as this first participant, which has a great change in the rating and a very low suspicion of our experimenters. We include those data. We see in this one that we can easily exclude them because they are very highly suspicious and there was almost no change in the data in their rating of whether we should change the colors or not. So say we're looking at a more ambiguous case, such as participant 423. You can see I've already included them, but I will delete that for now so we can show how our program works. So we have very little change in the rating in this particular case, but we also have a very low suspicion. But is it low enough to exclude it? The professor can set these parameters to say whether or not this is low enough to exclude or include it by using this program. You enter your participant number if you are the data enterer. You choose high choice and abstract as they were. Their initial rating was a 2 and their suspicion was a 4. It will ask us to confirm that this is the correct participant, and it will tell us we include the data. Another participant we might look at is participant number 207, who had a very small change in the change in rating. Actually, it's non-existent, and a fairly high suspicion, but we still aren't sure entirely if we should include them or exclude them. We'll go back to our sheet, enter their information. This time it was 207. They were low choice and concrete. Their original rating was a 1 and their suspicion was a 7. We then save this data. It will ask us to confirm, and you can see we should exclude that data. The next step in this process would be to continue with each of the participants that we aren't 100% sure about and alter the graphs to include only the relevant data, but we will not be doing this on this tutorial. Thank you for watching. That's all I have today.